All right, let's go over our second practice problem. We're going to be going over BF3. All right, so let's quick make our electron dot structure. Boron has 3 valence electrons, 1, 2, 3, and fluorine has 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. You'll notice that when I added all those little dots, I made it so that my lone electrons are nearby each other just to help make my drawing look a little bit neater. Okay, so fluorine, it has 7, it wants 8, it shares 1 of boron's electrons in order to get its 8, and boron is going to share 1 of each of the 3 fluorines. And you'll notice that when I do that, boron's actually only got 6 valence electrons. And that's okay. There are some exceptions to the octet rule. There are not many. Boron is one of them. If you'd like to know more about why boron is an exception, I'll have a Google Hangouts on Tuesday where I'll be available for just questions that you guys have about the problems that I posed, about just life in general. And so you can ask me then. It's not going to be on the test. I'm not going to ask you guys why boron's okay with 6. Just understand that boron's okay with 6. Okay, so what would the structural formula be? Well, we've got our boron, and we've got 3 bonds with 3 different fluorine atoms. And those fluorines do have some unshared pairs of electrons, so it would look something like this. Cool. All right, so what kind of shape is this? Well, you'll notice that the bonds that boron made with the 3 different fluorine atoms are as far apart as physically possible because of VSEPR, because electrons don't like being next to other electrons. And so it kind of formed a sort of triangle shape. And because of that, it's called trigonal, because of triangle, planar, because it is flat and in line with the board. The atoms aren't like coming out of the board, they are all in line, parallel with the board in a single plane that is also a triangle shape. So trigonal, planar. All right, I would like you guys to try a practice problem as well. Go ahead and try BI3. Pause the video, and when you're ready, you can unpause it, and we'll go over it to see if you're right. Okay, so BI3. Kind of similar problem. Boron with its 3 valence electrons, iodine with its 7 valence electrons. There we go. Once again, drawing the lone electrons near each other just to help make my drawing a little bit neater. And the iodine, it's going to share 1 of boron's valence electrons in order to be happy. And boron, it's going to share some of iodine's valence electrons in order to be happy. Cool. The structural formula will have a B in the middle with 3 single bonds connected to 3 different iodine atoms. A lot of people are going to forget this. Don't forget your unshared pairs of electrons on iodine. We've got 3 different pairs of electrons on each of the iodine atoms, and we do need to show that in our drawing. Cool. What type of shape is it? You got it. It's trigonal planar.